Hi everyone, good evening. My name is Olabi Adeneo and I welcome you to the last live coding session of the current stage. Hi everyone, good evening. My name is Olabi Adeneo and I welcome you to the last live coding session of the current stage. Oh, sorry. Can you guys hear me now? Can you guys
Yes,
hear me now?
we can hear you loud and clear.
Yeah. So we're taking a series of different visualizations taking a series of different visualizations to try and showcase how we can use pandas in real world scenarios. So I believe you can see my screen, and I'll just be picking it up from where we stopped last. So in the last live coding session, I just showcased the simple manner where you can plot. We try to plot a line plot of the different ages that were existing in the data set at that point in time. So today we'll be showing all of this and then trying to go through each line of code and what each line of code does as we are plotting. So the first plot we'll be showing is the BAP is the line plot, and then just as we did for the last time where we use PLT. So instead of us to keep typing in matplotlib.pyplots, we use this variable to try and shorten the variable name for the import. So we just is the standard is you can name it anything you want, but the standard is to always import matplotlib.pyplot as PLT. So we have two data sets here. The first one is x variables, and then this is y variable, so x and y. So when you use plt.plot, the default plot you get using the plt.plot is a line plot. And when you do a line plot, it just basically um tries to showcase what you have on the x-axis and matches it with what you have on the y-axis. And then these two like piece of code here is what we use to try and label each different axis. So after you make your plot, um Matplotlib initially labels the plot using the values that are inside whatever it is you are plotting. So to give your labels a name, you have to specify. You can see that for this plot, all we just have here have 45 then 0. There's no label. We don't know what is on the y-axis. This is the y-axis. We don't know what is on the x-axis. So to give these values on the x-axis a name and the y-axis a name, you use these two lines of code here. So you say you plot on the x, you give the x label, you give the x label an axis, and then you give the y label a name also, and then you can also give a title to the plot. So if I run this piece of code now, you can see that the y label has been labeled the y-axis, the x label has been labeled the x-axis, and this is just a line plot that is matching each x value. So you can see here the value of x is 1. When x is equals to 1, y is equals to 2. So what does that mean? When x is equals to 1, y is equals to 2. For the next one, when x is equals to 2, y is equals to 4. If you come back to the graph and you try to trace when x is equals to 2, you see that where it will meet the point will be at the point where y is equals to 4. So this is just a line plot that matches your x-axis values to your y-axis value and just tries to draw a line that can match each of those values together in a plot. So that is a basic what a basic line plot. So a line plot is a way for you to see the kind of one of the easiest use of a line plot is to see the relationship that exists between two list of values. Two variables is the actual term. So for this now we can see that the relationship that exists is as x is increasing, y is also increasing. So when x was 1, y is equals to 2. Then at the point when x was 2, y became 4. At the point where x was 3, y became 6. So we can see that there's a direct relationship that as x is increasing, y is also increasing. So and that is what this line plot is trying to show us. If we try to do it the other way around, and let us change this and put y, the values of y on the x-axis, and put the values of x on this axis. If we regenerate this plot, you will see that the line is going to show okay, it's showing a down, it's still showing an upward trend sort of, but what I was trying to achieve is a downward trend where we see that as the values of x as the values of x is reducing. Okay, is there a way I can do it? Okay, let me just try and do something like this. So y dot, let me try and sort this. Y dot sort. Okay, oh no, let me just use sorted y. I don't know if this will give me. So it is still giving me the same thing. So I want to try and show a line where this line is not going to be drawn this way. It's going to show a variation that comes downwards. So as x-axis going to 10. Okay, let me see, use the x. Let me see. When x is equals to 1. No, this is not. Sorry, let me print out the sorted y. So I want to do something where print out. Oh, so I think I can see exactly. So sorted y, then I should be able to say reverse is equals to true. So you can see now that now the line plot has changed from this direct variation. This one is showing another variation that as these values of y are decreasing rather, the values of x are increasing. So this is an inverse relationship. So when x is equals to 5, y is equals to 2. When x goes down to 4, then y is equals to 4. When x goes down at the point where x is at its lowest of 10, y is at its highest of, sorry, when x is at its lowest of 1, y is at its highest of 10. So these are ways where you can start to see a visualization of the relationship that is existing between two variables using a line plot. And then the next plot that we'll be showcasing is a scatter plot. So a scatter plot is basically almost the same thing as a line plot. The only difference is that a scatter plot does not try to give you a line. It just gives you different dots that denote where the x and the y axis meet. So as you can see, the only difference here is in the line plot we use plt.plot, but here we are using plt.scatter. So when you do plt.scatter, instead of you having a line plot, the result you have is this. And you can see that it's basically the same thing. The only difference now is that we are not drawing a line, rather we are showing the points where both of them meet. So yeah, we are showing that at points when x is equals to 1, y is equals to 2. This is the point here. When x is equals to 2, y is equals to 4. This is this point. And you can see that if you try to draw a line, it will get you back to this particular value here. If I also come here and copy this and I bring it down here and paste it here, you will see that it's also the same. So just like in line, at the point where x is equals to 1, our y is equals to 10. At the point where x is equals to 2, y is equals to 8. At the point where x is equals to 3, y is equals to 6. So a scatter plot is basically almost the same thing as a line plot. The only difference is that in your scatter plots, it does give you the dots that denotes where the values on the x and the and y axis meet. Meanwhile, the line plot tries to give you tries to fit a straight line into where these values meet rather than giving you the actual points. So the next plot we'll be talking about is a bar chart. And we all know what a bar chart is. So a bar chart just basically shows a list of different values for different categories using a bar. So the higher the bar, the higher the number of values that fall into that particular category. And you can see that the syntax for Matplotlib is very simple. We've been using the same thing ever since. The only difference that has been changing, the only thing that has been changing is what the function we are calling for the PLT does the kind of plots. So when we wanted a line plot, we use PLT.plot. When we want a scatter plot, we use PLT.scatter. Now that we want a bar plot, we are using what PLT.bar. And the difference between this now is that for a bar plot, you can provide non-numerical values as the x or y axis. So if you had provided something that contained non-numerical values for this plot, you would have gotten an error, because for this plot, both your x-axis and your y-axis, they have to be numerical in nature. But when you want to try and plot a bar chart or something like a pie chart, you can provide non-numerical values, and Matplotlib will be able to understand that okay, you are trying to show a bar chart, and you can see this is our bar chart. So for the bar A, so for people that fall into category A, the number of people fall stop at 10. But people that fall into category B, they get up to 20. People in category C are no more than 15. People in category D, they go as high as 25, and then people in category E are the highest with a value of what 30. So these are, you can generate a bar chart that you can use to just visualize the amount of distribution that each unique category falls into for a data set when you're trying to visualize it. When you're trying to visualize distribution. So the most times when you are going to the times where you are going to make use of a black plot most times is when you are probably trying to show the count. So if you are trying to show okay the amount of you have a data set, let's say a something like a gender column in your data, and then you want to show the different people that fall into the different genders in your data set. All you just have to do is to count the values in that category, and then plot a bar chart that can show the different values in that category. So the next thing that we're going to be showing is an histogram. So an histogram is almost the same as a bar chart, but the histogram just gives us a data set in different bins. So before I show you the histogram, let me just run this code here. Let me run it separately. So if you want this code, okay, I've not imported numpy. Let me import numpy as np. So after importing numpy as np, so this code here is giving me a what wow, this is quite a lot of values. So what this does is it gives a random normal distribution. So for people that are familiar with mathematical or statistical terms, so this is a random normal distribution where the mean is equals to 0, and then the standard deviation is equals to 1. So what a random number distribution is a statistical probability that tries to when you sum up the values in the array and you divide it by the number of values there, you should have the whatever you provide as the LOC, that's the location, which is the mean. And when you compute the standard deviation, you are going to have the value you have as the scale. So this is quite a lot of value. These are 1,000 different values. So imagine you are trying to, and for this kind of values now, something like this is very rare that a value is going to occur twice in this kind of scenario, because this is a lot of different values with a lot of decimal points. So at least there will be one decimal point that will make another value very different from another. So in a case like this where you have a data set with in a case like this where you have a data set with a different array of random numbers, where you know that it is very rare for two numbers to repeat itself. So in this kind of thing, we call this kind of data, we call them numerical data, or ordinal data. So these are data sets. This kind of data is a data where it deals with numbers that cannot be repeated. It's not categorical in nature. So this kind of data, the easiest way to plot this kind of data is using a histogram. So all you just have to do is, okay, for these values, I know these values are quite large. Let me take them in groups. So you can take values in groups of 10, you can take values in groups of 20, you can take value in groups of 30, depending as for however you see fit, and then you can plot it using a histogram. So when you create an histogram, all you just have to do is to pass in all of the different values that you want to plot. So Matplotlib, and then you have to provide the bins. So the bins gives you the what? The bins gives you the number of groups that you want to take it in. So Matplotlib is smart enough to get the highest number and then get the lowest number from this set of values, and then for every value that falls into the different 30 categories, for whatever you provide there, it will create an histogram that shows you all of this plot. So if you want this cell now, so this is the histogram, and you can see that the minimum value, so for this data, for this set now, the minimum value is -3, the maximum value is 3, and then different values there in the bin. So we have -3 to 3, and if you try and count this is probably going to be like this 1 2 3 4 5 and 6. So this is 5 bins, and it has been able to like divide all of the values that are here, this 1000 values, to try and show us, okay, for these different ranges, these are the values that are present in the data set. So you can see from -3 to 3, the range of values that show, they show, and you can see that if you are conversant with statistics and distribution, a normal distribution always has a bell-like shape, and if you try and plot, if you try and take a curve around each of these edges, you see that what you'll be having in the end is going to be shaped like a bell. And this is sometimes when you can just plot a histogram or plot a logarithmic distribution to just know if your data sets are normal, if they are normal. So based on this, you can know if they are skewed or not. But you talk more about that in the next stage, when you start taking live coding sessions for that stage. But just a very brief introduction. So this is a histogram. So range of values that fall between -1 and 0, around this range, and then that's what the histogram. So you have different customizations where you might not want your histogram to be mumbled up together like this. You might want each bar for each histogram to be separate, and then that's one of the ways that you can visualize your data. Another plot that we're going to try and show, okay, I think this is the same plot for Instagram. So another very very popular plot is a pie chart. A pie chart. Okay, I don't think I have that of a pie chart here. A pie chart should be somewhere around here. Sorry, let me just clear this. Let me just clear this here. Oh, say G. Exactly. So just before this bar plot here, you should also be able to create you'll be able to create a pie chart. So to create a pie chart, I'm just going to like, it's basically what I did for the bar chart. I'll take this, I'll copy and paste these values here also. But now instead of doing plot dot bar, I'm going to do plot dot pie. So when I do a plt dot py, I'm going to say that, okay, the labels, I'm going to say that the labels are the values, and then categories, and then give me the size to be equals to 5. So with this now, rather than what you have for a bar chart, you can see, even if you just try and stay here, if this comes, I can see this is the pie. So you have a lot of different options that you have for a pie chart. Okay, pie chart, explode is equals to none, data is equals to none, blah blah blah, labels, blah blah blah, colors, blah blah blah. So this is just me saying that, okay, set the labels to be equals to category. So if you try and upload this now, okay, that's size. Let me take away the size variable. So let me plot this. You can see that This is the pie chart. So for A, so what he tries to do is he tries to show you all of this in a pie chart. So we have five values: A, B, C, D, E, and E. We have five values of A, B, C, D, and E, and then for A, the we can say the value of A corresponds to 10% of the data. So you can see A is the smallest pie with just 10%. We can even make this right the value for whatever it's meant to write here, and I think it should be auto PCT, auto PCT, and then you format it with .2f. I think. Oh no, I think this one should be one, so it's incomplete format. And TF. Let me try it 1% at the back. And two, remove the F. I see. Which one is meant to be 2%? There's how they format this thing when you want to write the percentage of exactly. So this is the correct format. So you have 1% in front and then 2% below. So you can see that what this is trying to do now. This is, if you calculate this, 25 plus 15 is 40, 30 plus 20 plus 10. So this is like 100%. So you can't have a pie chart that is more than 100%. So what we are trying to do here is, okay, for category A takes 10% of this data frame, and then A just has a 10% aspect of this pie chart. And then we have category B. Category B has what, 20%. Then we have category C with 15%, and category C here is 15%. So these are, you can plot a pie chart. These are, you can plot a pie chart where you give different percentage for each of the values. So this is just a basic, very very basic introduction. So we have spoken on Instagram, then Instagram, sorry. So the next one that we're going to be showcasing is a box plot. So what a box plot tries to do is it tries to give you, rather than give you the distribution of the data using an histogram, it tries to put all of them into one single rectangle. So one of the very very best use cases for box plots is to showcase outliers in the data. So over time, as you begin to go in the data science and stuff, you see that box plots will be one of the plots that you'll be using a lot, because you'll be using box plots to check if your data set has something that we call outliers. So outliers are values in the data set that are very very far away from the normal range of values that you can see in the data set. So you can see this is just recreating the same data set, that the same data that we did for the pie charts, the histogram, sorry. But now let us try to see it in a box plot. So this is the box plot here. So you can see in this box plot what this value here. So any value that comes above this line here in the box plot shows that this is an outlier. So this value is too much, is very very much far away from most of the values in this data set occur in this box here. So we have some values that go up all the way here, some values that come down up the way to -2. So you can see that this -3 that we had here is almost an outlier, because even in this value here, this stops at -2, and then there's a value somewhere around there that's at -3. And then if you can see this histogram, after this stopped at 3, there was another value that was even away from this point of 3, this small value here that you can see here. That is what this dot here is trying to show, that okay, there's a value here that is very very much far away from the range of values that are what's popular in this data set distribution. So that is what you use a box plot for. And there are ways when you want to check if your data set has outlier, because one of the things that you must deal with as a data analyst or a data scientist when you are trying to analyze your data is outliers, because outliers have a way of changing the inference you are making. One very quick example of what an outlier is: so let's say in a locality, most houses or apartments there are being sold at around 20,000 or 25,000. But then something happened on a particular day. Let's say the owner of the house died, or they found that gold can be mined in that particular house, and then the house got sold for around 150 rather than the normal range of values of 20 to 25,000. So when you are trying to compute data, if you are trying to calculate the mean, for example, let me just try and showcase something like that here. So let's say I want to do np.mean. Okay, we have in that locality houses are being sold at 20 naira or 22 naira. We have 23, go back to 20, go back to 25, go back to 26, go back to 27, then we come back to 22, then we come back to 23, come back to 24, like that. So let's say these are the ranges of values of houses. So if you check this mean, oh sorry, this is meant to be in a list. So if you check this mean, you see that okay, the mean is also in between the frequent range of values that we can see is 23.2. All right, so when you go to the locality and you try to calculate the mean of the price of the different houses, you can see these values. It makes sense. But imagine that this particular house, on the day it was being sold, it was not found out that this house has something like gold in it. So instead of it to be sold at 23 naira normally, they want to sell it at 1,000, and it got bought. If we now try and calculate the mean of this particular value, see where the mean is, 112, which is very, very, very far away from the normal values of 2022, where every other house in the data set is going to be sold in. So this is what outliers can do to your data. An outlier that is to the right side will drag your mean very much far away from the normal range of values that you should have. An outlier that is on the left side will drag your mean very much lower than the value that it should be. So one thing you should do so that you won't be making wrong inference. So imagine you were analyzing a data and then you just make an inference that okay, we can confidently say that houses in this range have a mean price of 102,000, and then people now go to the locality and start saying that houses here are just being sold at 25,000. It was only one house that got sold at 1,000 there, and that was because it happened because of this particular factor that was not captured in the data set. You have already made the wrong inference because you did not take account of the outlier that showcased in your data. So a box plot is one of the ways that you can try and visualize. If I try and visualize this now using a box plot, let me say plt.boxplot. Okay, and let me try and show this. So you can see that it is showing the ranges of values that we have are here. See where these values are, but then we have an outlier that is showing that is very, very far away from this set of values. So any inference you try to make using this data this way, it will be wrong, because that outlier is taking you away from the actual inference. Because when we are making all of these inference or statistical assumptions, we are trying to do it that okay, when you take a random sample, at least 20 out of 30 or 24, like at least 20 out of 25, 20 out of 30 should follow 20 out of 25 should follow the 20 out of 25 um should follow the inference that you are making for whatever it is that you are doing. So if you have a data that has a lot of outliers in it, it will be hard for you to make correct inference, because that data, the outlier will just basically take your value away from the ranges of values that you should have. So that's what an outlier can do to your data set, and you should always try and avoid it. So but if you try and just remove this outlier now, okay, let me control y, let me just take away this outlier of 1,000 and then plot this box plot. You see that you can see your box plot is bigger, and because this is actually a confident range of values where your data set falls into for this particular range. So that's what you use a box plot for, and over time you continue to use it more as you go through a lot of different visualizations and stuff. So now I want to show some kind of customizations that you have. So with Matplotlib, there are some customizations that you have where you can begin to like change how your plot is going to be returned, because you can see so most of the plots that have been returning, they are not actually all that visually appealing. These plots are they are just the standard plots. So you
can just use it to see the data. But the essence of visualization is to have a way to represent your data in an appealing manner. So Matplotlib has provided us with a with an array of different features actually that you can use to change the color, change how your plot is being returned, and all of those kind of stuff. So let's say, for example, for this line plot now, if I try and redo the line plot, but now I'm saying that for the line plot, let the color be red. And I also want you to the line style, don't let it be just a straight line. It is going to be dotted lines. And then I'm going to have a marker. What this marker does is that it gives you what the marker does is that it tells it's in the line plot, it also shows the points that match. So if I run this code now and you see the value, you can see now that instead of just having a line, we are now also seeing just as what a scatter plot would have given us. But now we are trying to combine both a scatter plot and a line plot into one, where we are seeing the line and we're also seeing the what? We're also seeing the different values that are attached to this line as a point with a marker. So the marker says it's time. So to me, this is too big. I can reduce this to 4. And if I run this code, you see that the marker size would have reduced, and this is the marker. You can also change your marker type. I think you also have the option of X. If you use X instead of O, you can see this is an X. Then I can increase this from 4, let's say, to 6, and the X will be more evident that okay, we are marking all of these values using what? Using X. So that's one way of visualizing. Another visualization is for the bar chart. If I run this code now, you see that the bar chart exactly. So now instead of it to just be a blue color that is not appealing, now it's green. And we have also specified that the edges should be color black. So you can see that the black here is more defined than it was in the previous bar charts that we had. You can see the previous bar chart, I don't even think it had any edges, so this was just the color. But now in this new bar chart, we have tried to define the edges, and we have defined the edges in a finer manner. You can see that okay, this bar chart here, it has this, and it has what have you. So for the pie charts, if you try and do this, you can see now the pie chart, we specify that okay, you should show the value, and then we also specify that for each part of the pie chart, this is the color that corresponds to that part. So yeah, for the color for label A, give it a sky blue color. For label B, give it a light green color. For label C, give it a light coral floor color, and then for label D, give it a light salmon color. So that is another way that you can like make your charts more visually appealing and work on them in a good manner. So that's basically most of the major things about Matplotlib, because like I said, we can't really go through everything in this short time. It's just basically showing you a simple stuff. So if I share this my new tab also, just as I said for pandas, for W3 schools again, also serve as one of the best places. So rather than pandas, just put Matplotlib. So if you go to W3 schools for Matplotlib, they have a lot of a lot of different tutorials for how you can use it. What's the the getting started, you install it, and then what's pipe plots, how you can start plotting with different things. They have a lot of grids, how you can use this, the mean and median mode, even in W3 schools, to try and use NumPy and then try and visualize all of your data. So bar charts, lines, labels, how to use subplots. Subplot is something that you should learn how to use a lot, because with subplots you can see you can create more than one visualization in the same figure. And these are a lot of different things that over time in your next live coding session, because we are still going to expand more on this as the guys for the data storytelling track move to their track. You see a lot of different tools that you can use for visualization, even rather than away from Python. You'll be introduced to no code tools, where you just provide your data set and then you drag and drop the kind of visualization you want. And you also be introduced to more technical Python commands and Python functions that you can use to create more visualizations. And also even for the machine learning guys also, you see the aspect of EDA. Then how you can use the inferences that you use from your EDA to inform the kind of machine learning model that you'll be training on your data sets, whatever whatever it is that you are going to be doing. Yeah, yes, since today is the last live coding session, the since today is the last live coding session, since today is the last live coding session, the notebook and the notebook and the slide will be shared immediately after this session. And then I saw something about Seaborn. Yes, for guys that are going to the Python storytelling, you will use Seaborn a lot, and in the next live coding sessions that you have, you will be introduced to Seaborn and how you can use all of this to make most of these plots. Seaborn is something that was built off on Matplotlib, and they work hand in hand. So there were some tools and features that data scientists wanted when visualizing data that were not provided in Matplotlib. And with the way Matplotlib was created, it might have taken a, a lot of coding variants to create those in Matplotlib. So Seaborn is a module that was born from Matplotlib to try and bring all of these visualizations and have more customizations, more colors, and a lot of different things that one can use to navigate and do a data storytelling. So today we have come to the end of the live coding session, and so I just want to open doors for maybe questions and stuff like that before we end the session, because it's the last live coding session. Then from the next stage, everyone would have been shared into their respective groups, where in your respective groups, as have been stated, you start going deeper into whatever track of specialization you have chosen. So any question? My name is Adeniran. Adeniran Olabi is my name, and I'll. This is going to be my last session with most of you. But from the next live coding session, I'll be focusing more on the DevOps guys, and but your facilitators for the next live coding sessions will be introduced to you very shortly, and you also have a wonderful time of learning with them also. So Akim has his hand raised up. Akim, um, your question. Okay, I think that was a mistake from his side. That was a mistake from his end. Okay. So with that, I think we have come to the end of the live coding session. And what time is the stage 8 quiz closing? So the quizzes close 12 a.m. So the last time you have tomorrow to submit to make any submission is 11:59. After 11:59, everything is going to get reset, and then if you have not done any quiz, you cannot take it anymore. For the quiz, how much of coding do we have to do? Not much of coding. I think the quiz is a total of 20 questions, and then just about, I think, less than 10 questions are related to the data set. Some of the questions are related to concept and to text materials that text materials that are we getting text materials in the course, and then the remaining is based on the data sets. So the stage ALCS resource, it will be on Slack. It is going to be on Slack. We'll post it on Slack on the announcement channel for everyone to be able to have access to it. And then someone does ask if I can expatiate on how to use group by. So I said this, I think that was two coding sessions ago. Group by is a method for trying to group your data sets by a category that is easily available. Let me see if I can try and load in a sample data set. Okay, we have sample data set here. Okay, yeah, this can also work. So when you open collab give you some sample data set. So let me just say df is equals to, I don't think I imported pandas previously. Imports pandas as pd. So df is equals to pd dot read underscore csv. So let me pick up California housing tests. Let me copy this part and then let me paste it here. So this is our df. So if I do df dot head, so with our df dot head, these are the different values that we have in the California. So we have the median age, the total bedrooms, population, households, median income, blah blah blah, and stuff like that. Let me try and see all of the different. I think these are all the different columns that we have. But this column does, if I do df dot info, let me see. households. I'm trying to look for a categorical variable that I can use. All of these are numbers. I'm trying to look for a categorical variable that I can use to showcase the group by function. Let me see. Let me see the total bedrooms. df total underscore bedrooms. So plt dot plot. So I'm trying to see the range of distribution. So this cannot be used because the values are a lot. The values are a lot. Okay, let me just try and upload one from my game. Exactly. So now let me read this data. This data.csv. So let me do df.ed now. So here we have exactly. So this is the data set we used last time. So let's say for this, it's possible to have people that have the same education or people that have the same gender. So let me do something here. Let me do group by. So when you use group by, you need to specify the column that you want to group the value by. So in this data set now, I want to group it by the gender. So I'm going to say gender. And then when you do a group by, you can't just see the value of what you did. You have to like perform you have to like perform a action before you can see a value, because the group by object is like it gives you a sparse matrix. So it's a group by data frame. So let me say I do something now, dot sum, for example. When I do this now, you will now see that the result is going to be just the two different unique things that are existing in what you are grouping by. So I'm grouping by what? By gender. So when I'm doing sum, so every value in that data set that belongs to the female gender, it will sum it up. But because this is a text and not a value, so that's why it is just adding all the names together. And then these are the names of all the guys. And then the female total age. So if I sum up the age of every female in the data set is up to 256. The city of every female is this, the total salary of females is this, and so these are you do group by. So when you do a group by, you also need to perform an option. So what group by does is when you group by a particular column, it checks each of the unique value in that column and then extracts every row where that particular column is equal to the current unique value. So if I do something like this now, when you do a group by, there's something called get groups. If I remember, if I'm correct, get groups, and if you do this, okay, there's no get groups. I think it should be groups. Exactly. So when you do God groups, you can see this is telling you that after you perform this group by on the data set, we have what? Females and what? And males. So every female, so the row that is in row 0, it belongs to the female category. The row that is on row 4, it belongs to the female category. The row in 6 belongs to this category, blah blah blah. Then we go to the next category. The next category is the male category. Row 1 belongs to the male category. Row 2 belongs. If I want to say, okay, rather than grouping by the gender now, let me group by the city and do the same thing. You see that we have different cities. So we have Boston in this data set. We have people that are also from Chicago, other people from Los Angeles, the other people from New York, from San Francisco. So the row of row 5 and 11, those are the people that belong to Boston. The people in row 2, 8, 14 are from Chicago, and then people in 1, 17, 13 are in Los Angeles. So that's what group by does. It allows you to take a particular column where they are categorical variables. So you cannot try to do a group by with the age column, for example. It does not make sense because there is lesser possibility for different people to have the same age range than the possibility of people to come from the same place. So most times when you want to do a group by, oh, you are not seeing my collapse screen. Sorry, somebody should have somebody should have tried to unmute. In times like this, when it's probably something about my screen and stuff, you just try to like unmute and tell me. Sorry for that. I thought I was sharing my window, not my tab. So let me share this tab. So you can confirm now that you can. Oh, admin has locked ability for you guys to unmute. Oh, I see. Apologies for that. Next time I'll be sharing my window rather than my screen, so we won't be having this issue. But yes, what I did was I first read this data set in. So I read this data sets in, and then if I do like a df.edge, so we'll see that this is a lot of a data set that contains the name of people, the age of people, their city, salary, gender, education, and what have you. So when you do a group by, I was showing that if you just do this to do a group by, I started with the gender column. So you have to provide the name of the column that you want to group the data set by. So yeah, I'm providing the gender column as I'm providing the hope you guys can see my screen now. If you can see my screen, I can just like send emojis or something. Okay, yes, you can see my screen. Yeah, thank you. So let me continue. Okay, so let me continue. So as I said, when you perform a group by function, what is returned to you by pandas is a generic object that you cannot access like that. So if I group it by gender now and say let me try and access the age or something, you see, even trying to access the age is still going to be a generic object. Before you can see the values of what your group by is going to give you, you need to perform an aggregation function. So aggregation function is like function that combines different values together. The major aggregation functions that are provided are the main function and the sum function. We also have something called the max function. We also have the main function, but the major ones that we use are the main function and the sum function, because the idea is that when you are grouping by a particular column, you want to see the set of values that belong to that column or something. So in this column, for example, now I've grouped by the gender. So I want to see, okay, let me try and see that what is the minimum value of the salary of people that are in different genders. So what this will do now is it will go to the gender, select, okay, let me use some, because min cannot cater for text. Some can cater for text. So what is doing, I can see in this gender we have just two different genders in this data set. That's the female and male, and that's why we have just two values here. So what is going, when you perform an aggregation function, what it does is that it goes through the data set, and for each of them it selects the rows that belong to a particular group, a unique group, and then perform the aggregation function on them. So for basically for the female group, these are the summation of the names of every female in the data set. The total age of every female in the data set is 256 years of age. Then the summation of the different cities that they come from. And then the sum of their salary is 970,000. It's the same thing for male too. It sums up all of the names, sums up the age of all of the men and something like that. So the way it works is that when you do it, so there's this function called does groups, or it's not a function, I think it's a method, because you cannot call it. So when you call this method, what this does is that it shows you every unique category in that column that you specified, and each of the row that corresponds to that category. So basically in this data set now, for the female category, row 0, row 4, row 6 up to row 14, these are the rows that when you check their gender, they are females. For the male category, row 1, row 2, row 3, row 5, 8, 10, up to 15. These are the rows that when you check their gender, they are in the male category. So this is what group by does. So let me say I change this now from gender. Let me change this to city. And if I change this to city, you can see now we have a lot more city. So instead of those two, we have Boston. People from Boston, the only rows where if you check their city, they are from Boston is what, row 5 and 11. For Chicago, it is row 2, 8, 14. Los Angeles is 1, 7 and 13. In New York, you have row 0, row 6 and row 12 and the like. So when you use a group by function, that's what it does. You use that column to check the different unique values that are in that column. After you check the different unique values that are in that column, you can then, after you check the different unique values that are in that column, you can then try to show each of these values. So if let's say for example, I know that okay, Boston is actually a group here. If I copy Boston now and now do this, say get group, and now put Boston here. If I run this will now give me all of the rows that belong to what? That belong to Boston. So if I just take this away and try to get another group, let me say Los Angeles. Let me say Los Angeles, and then let me use Control Y. Exactly. Let me change this from Boston to Los Angeles. What this will do too is it will go to the game. So after you perform a group by, the only way you can see the values that belong to a particular group without performing an aggregation function is if you use this get group function. But most times when we do a group by, we just want to do like a summation to see, okay, in this particular group, what is their mean value. So something like this now, I can do count. So you can see that with this now, this is returning a value. Okay, in Boston, the number of people in Boston, their count is what? 2. The age is 1, salary is 2. So that means somebody in Boston now, the age was not present in this data set. For Chicago, we have what? 3 people, 3 people. So that means everybody that belongs to Chicago, every of their column was complete and stuff like that. So let me say, for example, now I want to use a bar chart to know the mean salary of different people that come from a particular city. So after grouping by a city now, I will get the mean, or no, after grouping by the city now, I can get the mean. Okay, but before I get the mean, let me just get the salary column, since I know that I'm trying to get a mean and the mean cannot work with this. So if I do this, so you can see for each city, in Boston, their mean salary was what? 120,000. In Chicago, their mean salary was 123. But rather than seeing this as a value, Pandas also perform us with something called dot plots. So if I do this dot plot and I say kind is equals to, I want to plot a bar chart, and I run this code, you see this has automatically generated a bar chart where I'm seeing the mean value of each of these cities. So the mean salary for people in Boston is around 120,000. That of people in Chicago is around 120,000 also. The state or the city that has the highest salary is San Francisco, and this is what visualization can give us, because you just have to look at your data once and you can make an inference. So with this now, I can say that confidently that from this data set, the city that has the highest average salary is San Francisco. So that is a brief exact used on groups method. Yes, it's only when you perform the group by function that I can start using all of these functions. Another advice I give to a lot of people when you're starting out is you have to try and learn to read documentations, because most of these codes and libraries that we're using were not written by us, they were written by people. And these guys that wrote them, they have a particular naming convention, they have a way they wrote this code and expect this to be used. So you have to be able to go through documentations of libraries for you to understand the functions that they wrote, and for you to understand how you can begin to use these functions in your own code. So I'll be taking the last question from today, which is from Nathaniel. I think he has his hands raised up. So that will be the last question, and we'll end this live coding session, and then we'll pick it up from there. But I won't be the one handling the live coding session from the next stage. Each track, the data storytelling has their own tutor. The data engineering guys have who is going to be in charge of it. I will be the one for the DevOps guys, and then you see a lot of different things that we can start to use. So if Nathaniel is not asking any question, I think we have come to the end of today's live coding session, and the materials will be shared on Slack. And we hope you all had a great stage A, and in the next few days we'll welcome you all to stage B. So bye bye everyone, and have a nice week.